Okay, so today I'm going to teach you to take a set of data table, an input-output table, and enter it into your calculator, and then fit the information, the points, the scatter plot that's created, to a regression equation. Okay, so the first thing I want you to do is turn your diagnostics on. So to turn your diagnostics on, your stat diagnostics, we're going to go to mode, and down here where it says stat diagnostics, we're going to go ahead and arrow down, and we're going to turn that on. That way we can see our correlation coefficient and all kinds of other good stuff. So you just arrow over and click enter, and then just clear to get out of that screen. All right, so now we're going to enter these statistics here. So to do that, we're going to go to our statistics button, and we're going to edit a list. So here in list 1, we will be entering all of our values for X. So let's do that. 0, 1, 2, 3, 4, 5. Then we'll arrow right, and we'll enter 293, 333, 344, 360, 380, and 402. Enter. Okay, and so you can just double check your data, make sure your statistics match. Okay, so now we're going to go ahead and calculate. In this case, we're going to do a linear regression. So hit statistics again, and we're going to go to calculate. So you have all these options here. We're going to do number 4, which is a linear regression. Okay, so it's telling us that our X list is in list 1 and our Y list is in list 2, and that's where we stored them. We're going to skip frequency list, and we're going to store the regression equation in our Y equals here in Y sub 1. So to do that, we are going to go to alpha F4, and we're going to store it in our Y sub 1. So again, that was alpha F4, okay, and hit enter. And we have stored it in our Y sub 1. There's a couple other ways to do that, but that's the fastest way that I can find. All right, so now we're going to calculate our linear regression in mx plus b. Y equals mx plus b. So we're going to calculate, and here we have our y equals mx plus b, or ax plus b, where our slope is 20 point that beautiful value, and our y-intercept is 301. And then our correlation coefficient, which is our r, you can notice that it's really close to 1. And so this is a really good choice for our a linear regression was a really good choice for that data, because this correlation coefficient of 0.98 is close to 1, and the closer to 1, the closer those points are to the same line. Okay, so now let's go ahead and go to our y equals button, and what we want to do is first make sure that we have our plot turned on. I always like to see when I have a set of data that I'm entering, I like to see those points. So if you hit enter, you can turn the plot off and on. So now it's blinking and it's darkened, so it's selected. And what we're going to do now is graph this. So we're going to go to zoom, because if we just hit graph, we might not see this data at all, because these y values are so high off of a normal coordinate plane. So if we zoom to zoom 9, number 9, zoom statistics, you can see there is all of our points. Those are those little boxes there. Those are all the points we entered. And then here we have our linear regression, which is this line that's created here. And you can see that this is a really good line, because let's say you have 1 point that's below, maybe 2 points that are below, and 2 points that are above the line, and then 1 point that's exactly on the line. And you really can't get any better than that. And you can also see that the points are really close to they make a linear path. And so there you are. That's how you do a linear regression. Now, if you want to do multiple linear regressions, like you have multiple problems to do and you want to clear your list out, there's a couple things you can do. What I like to do is just go second and hit the plus sign and hit into our memory. And I just like to hit number 4, and that clears all the lists. So when you go back to enter a new set of data, your lists are empty. And that's how you do it. Good luck to you.